So in the last class we started the second module, that is addressing mode. So after the addressing mode, again today we are going to discuss the arithmetic instructions, or we can say arithmetic operations. So already know that in the arithmetic operation is nothing but those are the add, subtraction, multiplication and division basically. So apart from that we are going to add some other instructions also. So those are here the INC, this is also the instruction. So it is meaning like that increment. So DEC, this is a decrement. And here the add, addition, slash, next addition with carry. So this is the ADD is slightly different from the ADDC. This is the addition, this is addition with carry. So next one is the SUB, again double B, that is the subtraction with borrow. Next one is the MUL, multiplication. For the division it should be the DIV, division. So last one more, it is their decimal adjustment for addition. So that means totally 7 instructions are there in the arithmetic operations. So here I written these are the syntax format. Increment destination only, there is no source at all. This is decrement destination. Similarly add, destination comma source. Similarly subtraction, it also consisting destination comma source. So here these are the direct mul AB, division AB, DA space A. So we need to start the one by one here. So when you are performing the arithmetic operations, already we know that PSW, program status word or flag register. So in that, when you are performing the arithmetic operation, some of the bits it is going to make changes the values in the PSW. So those we can call it as the flag bit or the flag registers. Those are carry flag, auxiliary flag, auxiliary carry flag, overflow OV, overflow flag. One more is the parity flag. So these all the bits which are we seen in the PSW register, these contents it is going to get altered under the operation of the arithmetic operations. So in the first one we will see what is meant by the increment and decrement operator. So increment and decrement operator, when you want to perform the sum of the operation, unless we need to get the results, at the time we are going to use the increment, INC increment, DEC decrement operation. So increment means it is like just plus 1. Whatever you need to perform the increment operation, it is will perform by the plus 1 only. Decrement means it is something like the minus 1, that's it. So already we know that in addressing modes, so almost this increment and decrement, it is going to support almost all the addressing modes. That may be the register addressing mode, indirect register addressing mode and direct register addressing modes. And already I said in the arithmetic operations, flag bits, that is nothing but the bits of the PSW register. So none of the flags, they are not going to get affected by the increment and decrement. That is nothing but it is going to perform only the plus 1 or the minus 1. That means these flag bits are, they are not going to change under these instructions. That's why none of the flags are not going to get affect here. So for example, you can see here how it is going to make the changes here. If I write the move a comma hash 3ah, so I already know that if I write the hash symbol, it is the immediate addressing mode. I am loading the 3ah value to the accumulator A. That means here A equal to 3ah value. If I write the decrement, DEC, decrement space A, that is meaning like that even here I am going to perform the decrement operation for the accumulator. So what is the previous value? This is a 3a. Decrement means minus 1. So 3a minus 1 means it is a 39h. Behind the number of a, that means that is a 9. That means minus 1 means that it will become 39h. Or see one more example. Move space R0 comma hash 15h. That means here I am going to make a point out to the memory location 15h by the R0. Or you can say this immediate addressing mode. I am loading R0 equal to 15h. In the second one, move 15h comma hash 12h. I am loading the value 12h to the one of the memory location. So this is a direct addressing mode. I am loading the value 12 to the 15H, some RAM address. That's why 15H becomes 12H. If I write increment operation such a way that increment add or not. If I write increment add or not means I need to perform the increment operation for the content of or not. So what is the content of or not here? Content of or not means here I am taking the 12 here. Content of or not, because 15H is a memory address is given holding by the R0 itself. That means if I want to perform the increment operation at or not means I need to perform increment for the content. That means what is the content here? 12. So I need to perform the 12 increment plus 12 means it becomes 13H. That means whatever the content 12 in the memory location 15H is going to get increment, means 15H become 13H because I need to perform plus 1 to the 12. Similarly, if I write decrement 15H in the sense, again whatever the increment here, this is 13H I got. When you write decrement 15H is nothing but again it making the minus 1. 13 minus 1 means it become the 12H. So for similarly, if I write increment space R0, that means I need to make the increment for the R0 memory address. What is the memory address here? This is 15H. That's why R0 it becomes equal to the 15H means 15 plus 1 means it becomes 16H. So last one more example. Move dptr data pointer comma hash 1 to FF. I loaded the sum of the values or the memory address to the 1 to FF. If I write increment dptr, at the time I need to make 1 to FF plus 1. At the time it becomes the 1300H. So this way we need to use the increment and decrement operation, just like plus 1 in the increment, minus 1 in the decrement operations.